We actually don't need a heat of reaction if we use the elements as found in nature as our hypothetical path. So, what we're going to do is take all of our reactants, our 40 moles of A, 40 moles of B, and 20 moles of liquid water, and we're going to calculate their enthalpies relative. So the enthalpies relative to the elements. At 25 degrees C. That will be our reference state. So if you are on the tab using elements, you'll notice that the enthalpy table again has the material balance numbers in there already and what is in those enthalpies. So for instance, the enthalpy of A in will be the enthalpy required to go from the element as found in nature at 25 degrees C to the molecule at the inlet temperature, which is 75 degrees C. So this is the heat of formation of chemical A plus, that gets us from the elements to the molecule, but at 25 degrees, and so plus the integral from 25 to the inlet temperature, which is 75, Cp dt. And this is the heat capacity of the gas. A similar calculation would be done for B. For the liquid water being fed, we have HDN. Fortunately, we have the heat of formation of liquid water. If we didn't, if we had only the heat of formation of the gas, we'd have to make an enthalpy change to correct it for being a liquid. But here we do have the heat of formation of the liquid. And so again, then this would be 25 to 75, the integral of Cp dt, where this is the liquid heat capacity. For the outlet material, they're all gases, and so they all have a similar calculation. So for instance, HD out, this is equal to the heat of formation of gaseous or vapor. This one here, just to remind you, was for the liquid. The heat of formation of the water vapor, but that was at 25 degrees, and so we have to go from 25 degrees to 300 degrees Cp dt. This again is the vapor. So all those enthalpies are calculated and summed up, and we find that Q is equal to minus 2857 kilojoules. Now this is off by about 3 or 4 from the previous calculations, and I believe there's no mistake here. I think that is just an error in summing up these, a rounding error or something like that of adding up all these enthalpies. All right, so this is how you would calculate the, formulate the enthalpy table if you don't have the heat of reaction. and just using heats of formation.